Hello friends, welcome to another fun edition of Easy Maths Tutor, and today we're going to solve linear equations. We're going to binge on some linear equations, but let me give you a little background. What are equations? Equations are mathematical statements that try to solve problems, that try to find unknown numbers, okay, represented by a letter. And then one of the rules of equations is that whatever you do on the left-hand side of the equation should be done on the right-hand side of the same equation. And these are called inverse operations. That means if you have a term that is positive and you need to move it to the other side of the equation, then you have to perform the inverse of positive, which is negative. Or if you have a term that is in the multiplication operation, for you to move it to the other side of the equation, you need to divide, and vice versa. So we're going to apply inverse operations in solving linear equations. Now, this is our first problem. First problem is 5x plus 7 equal to 2x plus 13. And we are supposed to find the value of x. Okay, so the way we're going to solve this, we're going to move all the terms of x to one side and all the terms without x to another side. And we're also going to try to isolate the equation to the extent that we have only x, thereby finding the value of the equation. So let's solve the first one. Solution. Solution to this problem, 5x and 2x move to one side. 5x will stay where it is. 2x on this side, we need to move it to this side. Now 2x is a positive term. So when it moves to this side, it's going to turn to a negative. Okay? 7 is a positive. Therefore, if we move it to this side, it becomes a negative. So 13 will remain on this side. 7 becomes negative. Therefore, we have 5x minus 2 gives you 3x. 17 minus 7 gives you 6. Now, we need only x to be on the side, not 3x. So how do we remove 3 from the x? Remember, when you have a number mixed with an algebraic term, it is mixed together using a multiplication sign, okay? So if you have something like this 27, this is a complete integer. But if you have something like this 2x, means that you have 2 times x, okay? So now let's go ahead. So we have 3 times x. So for us to move 3 to the other side, we need to perform the inverse of multiplication, which is division. So we're dividing both sides, or the first method is to divide both sides by 3. The second method is to move 3 to the division sector. So we separate 3 from x and move it to divide. Therefore, x is equal to 3. And so now, we're ready to solve the other questions that we have for today. So, we have today 7, all bracket x minus 3, bracket close equal to 2, all bracket x plus 7. So now to solve this problem, we're supposed to find the value of x for this equation. But first of all, we are going to expand these brackets. That means we're going to multiply 7 by all the terms found in this bracket. Then also we're going to expand these brackets. And after expanding this, to rearrange all the values, terms of x on one side, and rearrange all the values that are constant on the other side, and then we're going to make x isolated on this side. So let's first of all expand this bracket. So we have 7 times x will give us 7x. Then we have 7 times minus 3 will give us minus 21. Put your equal sign. Then we have the next expansion. So we have 2 times x will give us 2x. Okay? 2 times 7 will give us 14. Now we are ready to group our terms. So we're going to group 7x and 2x, and group negative 21 and 14. So 7x and 2x. 2x is positive on this side, but it needs to be on this side. So it's going to become negative. Negative 21 on this side will become positive 21. So let's rearrange. So we'll move this, has 7x. We'll move 2, it becomes negative 2x. We'll move 21, it becomes negative 21 becomes 21 plus 14. Are we good? 7x negative 2x gives us 5x. 21 plus 14 gives us 35. And remember what I said about 5, a number and a letter being paired together. A number and a letter being paired together is paired together using the multiply sign. So that means for us to move 5 from this side to this side, we need to divide. So there are two methods. We can either divide both sides by 5, or we move 5 to the other side. So we say x equal to 35 over 5. So now using the crossing out method, if you divide the denominator by 5, you have 1. And also divide the numerator by 5, you have 7. Therefore, the value of x is equal to 7. Thank you. Now let's go ahead to the next. In the next problem, we have 5x plus 3 equal to 9x minus 13. So we rearrange, we move it around. But I like to always move to the greater value of x because it gives me a more positive value. So let's try. So I'll say I'm going to move positive 5x to this side, making it to become 9x minus 5x, while I move negative 13 to this side, becoming positive 13. I hope you're following me. So therefore we have 16 and we have 4x. So I would just like to rearrange it to look like this. 4x equals to 16. And then once again I'm going to move 4 using the inverse of multiplication, which is division. So we have 6x equals to 16 over 4. Dividing the denominator by 4 gives you 1, and dividing the numerator by 4 gives you 4. Therefore, x is equal to 4. There we go. Now we have this problem. How do we solve this problem? Now we have to make sure there are no ratios, there are no fractions, okay? So how do we do that? We're going to move the numbers in the denominator across to the numerators. Okay, so let's go right ahead. So we're going to have 5 will move here, 5 will move here, giving us 5 bracket x plus 5. Okay, and 4 moves here, giving us 4x plus 7. Are we good? Okay, so we're going to expand this equation first of all before we rearrange. Therefore, we will have 5x plus 25 equal to 4x plus 28. Okay, now we have this, we're going to move them where they ought to be. So we have 5x minus 4x. Remember, 4x becomes negative on this side, and 25 becomes negative on this side. So we'll have 28 minus 25. That will give us what? 5x minus 4. 5x minus 4 will give us x. 28 minus 25 will give us 3. And there we have the final answers of our linear equation. See you in our next video. Bye.